So Scilab activities as a part of FOSSEE project is handled by Professor Kannan and by me. So this outline of the few slides that I will present now. So we have a few activities. Textbook companion project is one of our main activities which we started earliest. So we take a, many of you might already be aware, but as I said, this is an opportunity for all of us to, we'll discuss more about the textbook companion project tomorrow also. So what is this objective? What is the textbook companion project? We take a textbook, a typically standard textbook that is used, and the student chooses a textbook, not necessarily from Mumbai, not necessarily from IIT, anywhere from within India, and only the solved examples they will solve within Scilab. Yeah. So often the author of the book has used some other numerical package, maybe they've used MATLAB, maybe they've used some other proprietary package. So the objective of the textbook companion project, which we will call TBC, is to just work out all the solved examples in Scilab. So the student learns Scilab, they learn one particular subject very well as a result of this. They avail all technical help related to the subject from their teacher there, and we provide the Scilab help, and also we review the code. So also the FOSSEE team provides a web interface. We since the last 2 years we are also providing execution of these codes on a cloud. So this sort of promotes the usage of Scilab. It also provides us documentation for Scilab for that particular subject. So because the student doesn't have to explain anything, the explanation is already there in a standard textbook. Also none of the problems are reproduced in the code, and very importantly it demonstrates that Scilab is suitable for this particular subject. Yeah. So just to give some numbers, we have around across the last 5 years 439 books are already completed, another 235 books are in progress, and these books are across these different areas. Yeah. So just to give an idea that for these different types of textbooks, already Scilab has been demonstrated to be usable in all these. So another very important activity that we have proposed over the last 3 years is lab migration. So what we realized that students are learning Scilab, but they are still having to use MATLAB in their labs. Yeah, for example, in some particular college, if they are having a digital signal processing lab, yeah, there the laboratory in charge is using MATLAB for all those problems. So if we migrate the lab, if we help the college to shift to Scilab for all these same problems, typically the university prescribes the problems, maybe the college decides the problems, at least the package is not prescribed by the university or the college, so we will shift all those from MATLAB to Scilab. So so the lab migration team, we suggest different ways by which Scilab can be used for that particular lab, and we typically involve the particular college teacher or and the students. If required, we also provide the code for this particular purpose. So this is what is lab migration. This is when even students in the lab will all use Scilab for that particular experiment. So lab migration, we have had 31 which are completed across India. So I am not able to list all these colleges. These are just some. Let me just go to the website. So we have, this is a list of colleges that we have. There are some other colleges who have also migrated, but we don't have their code yet, but they have been using Scilab in their labs. Yeah. So typically one college might have 3-4 different labs. So this is where we have involved the colleges. Okay, so here also on our website, the scilab.in is where most of the all the information is kept about our activities. So the list of completed books can also be found on the website. These are the different areas. Exact names are also here. The objective is that each student, before they propose a book, they will not propose a book that is already completed or which is in progress, which has been proposed by somebody else. So students are able to see all the books that have been proposed and which have been completed. So they will propose a book outside this list. Yeah. So these are the different books. Much of our outreach has been through the workshops. So initially when our project started about 5.5 years ago, we had lots of workshops where we conducted the workshop face to face. We had participants like in a classroom. We have several 2-day workshops and more than 70. We have 5-day workshops spanning different areas. But then this involved typically lots of travel. It involved teachers that had to take leave from their college, and it was not scalable. We had too many requests for conducting workshops, but not enough number of members in our team. So what was very easily scalable, thanks to Professor Kannan's suggestions, was to use spoken tutorial based workshops. So spoken tutorial itself is a screen grab accompanied by audio also. So in that sense, it is a tutorial and a spoken tutorial, and typically one topic is about 10 minutes. So there are lots of spoken tutorials developed by the spoken tutorial team. The Scilab team, the FOSSEE team has helped in the Scilab spoken tutorials. They are also available, many of them have been dubbed to local Indian languages. So we use these to conduct workshops, and these are now at no expense to the participant nor to the college. We also conducted tests. So this number of workshops and number of participants is a very quickly changing. Yeah, every day we have workshops. So that can also be checked from the spoken tutorial website for the latest. So please, this is the link from which I picked the number of workshops and the number of sorry. So as of today, close to 1,300 workshops in Scilab have been conducted, and the number of participants is more than 50,000. This is across different Indian languages. Yeah. So important is that these are free now. There's no expense involved in neither in terms of travel, and the CDs etc. are provided from us. We also provide a Scilab expert who answers queries on Skype. Another of the important activities is that Scilab can be executed on the cloud. Yeah, all these Scilab textbook companion projects that have been completed, all those codes can of course be downloaded. They're all open source. In addition, these can also be executed directly on a website, on a cloud, through a browser. Yeah. So Scilab on cloud is the name of our activity. It's a web application that facilitates running Scilab from within a browser. So typically a student could take a solved example, they could change some parameters, execute it directly, see the plots on the browser. If required, they can certainly download the code and also install Scilab on their own computer. But installing Scilab on one's own computer requires installation of the toolboxes. It is also dependent on whether it is Windows or Linux or Mac. But one can also run Scilab from a browser if it is on the cloud. So this is also something that the FOSSEE project has developed. So more details about this is there in the presentation, and this presentation itself will be kept on the Scilab website. So I do not want that we spend time in taking down exact website, etc. Yeah. So if there are any queries, then we will like to discuss that here. So some other activities of the project that I did not talk about now is that we also have Sandhi that we spend some time today. And we also, Professor Kannan's team has developed OSCAD, which is from within the same package. One can design right from PCB, one can simulate the circuit, all using open source. And this used to be done in different open source packages before. Now there is one integration by which one can right from design the circuit to simulate it, to extract out state space models, transfer function models. Also another important activity is hardware development, so that typically colleges, they use some ready-made kits, perhaps by LabVIEW, perhaps by Conzer. These are typically very, Conzer for example gives you MATLAB code. They want you to use MATLAB along with their hardware. Yeah. So one of the things that has been developed by Professor Kannan's team is about control experimental kits that can be completely run perhaps using a browser, but can be run on Scilab together with the kit. So these are some other activities over which I am not spending time now. Yeah? Yeah. Okay, are there any queries? If there are some things which Sir Kannan will add. Thank you.
Hello again. So in about 10 or 15 minutes, I just want to give an overview of some of the things that we have done. In fact, so I thought that I would give a demo of some of the things. Let me start with FOSSEE.in. Okay. So FOSSEE stands for Free and Open Source Software for Education, and it's the umbrella organization, umbrella project that coordinates various projects. One of them is Scilab, and you will get to know enough about Scilab, what we are doing, and so on. And I think, in fact, we should start with Python, because Python is a activity led by Professor Prabhu Ramachandran. Okay, Python is very good because it can be used as a glue language. You can use Python to connect various open source software systems to come up with new software. Okay, so it should not be in the open source community. We should not even be discussing is Scilab better or Python better. But we should discuss, can Scilab and Python together compete with MATLAB, compete with, say, LabVIEW. So that is the stand we have taken in the FOSSEE group, that we will work together. So Python is very important because it's a glue language, and also it has excellent graphics. Okay, very nice interfaces and so on can be done using Python. Okay, let me go back here, and we have OpenFOAM. So OpenFOAM is a computational fluid dynamics software, and CFD, and it's the state of the art. One of our colleagues, Professor Shiva Gopalakrishnan, is leading it, and so here you see that it's a replacement for commercial packages like Fluent, Star CCM, and so on. It's an equivalent to Fluent. Okay. Okay, and then the next software is OSCAD we came up with, but then it sounded like ORCAD. So they, Cadence people came and said, please change the name. And so we were very happy that, it was just 2 years of work, whereas Cadence has been working for many years. We were happy that, they came and told us they thought OSCAD as a competitor to ORCAD. So we're very happy with that. We still haven't decided on the name. We might even call it LibreEDA or something like that. What else? Optimization. So we have another group that is looking at this set of suites, this suite called CoinOR. So trying to bring optimization, strengthen the optimization effort. So you don't have to note down, these are all available through FOSSEE.in. Okay. The other thing that I wanted to talk about is the methods that we have established for one software is replicated across all these software systems. For example, Professor Madhu Belur discussed about Textbook Companion. Textbook Companion is a very easy way to provide documentation for Scilab. Supposing a professor comes and says, I am using MATLAB because there is no good documentation for Scilab. Using this thing, I can ask that professor, what course are you teaching? What book are you using? Here is the Scilab Textbook Companion. This Textbook Companion has Scilab coded for all solved problems of your textbook. Okay, there is no need to use MATLAB. We have already, finished more than 400 books, 430 books. Another 250 books are in pipeline, right? So it's of course it's also very good for the students They go through a problem and they say, okay, here is the example, and then I have a question, what will happen if I double the resistance value? Okay, you have to go through the calculation, but you can just come and say, come to textbook companion, double the value, starts running. Okay, matter of fact, I think we should give a demo of that. Let me just take, and put it here. Let me go to cloud.scilab.in, and it has all the, of course, this is, dynamic. So you can actually, if you have internet connection, you can actually execute things. So if you say that, let me say A equals 1, 2, 3, 4, and then I say I want to calculate determinant of A. I want to calculate the eigenvalues using this bad word spectrum. Okay, you execute, and all the commands go to our Garuda cloud in Bangalore, and depending on the internet connection, the speed and so on, the computations happen and you get the output. You can see that it is executing. Let's hope that it will come soon. Okay, there it is. You can of course modify. So I'm going to give, so this is the cloud that we established. Okay, so Python Scilab is available on the internet. You don't even have to install it. Any browser will work. You can use your smartphone, you can use your iPad, you can use your Akash. Okay. Now, in this, we hosted all our textbook companions. So, for example, so I'm going to give an example from my area. Let's take control theory and control systems. We can take some other example also. Let's take BCCO, which is a standard textbook. Let's take frequency domain analysis, and let's take Bode plot. The reason being, I want to show a plot being shown. Okay, here it is. The moment I select the book, chapter, example, the example appears. I can always go and change this if I want, right? But let me execute this. When I execute, once again it goes to Garuda. It goes to Bangalore. Okay. If people don't have internet connection, we have the same thing available for offline use. You can download, use it, you can copy paste it, you can do all kinds of things. Once the plot comes, you can save it. Here you see that it says download book. Download book means collection of examples for the entire book. This is only for a chapter, it's only for a particular example. The code is available and the contributor information is here. You can report the bug, give feedback and things like that. You can see that it is taking a little bit of time because it has to send the result, which is ASCII, plus there is also a graph. There it is. Now you can, let me see, you can even save the image, correct? Now, if you see, if you go to scilab.in, under the textbook companion project, under the completed books, you have details of, Professor Madhu Belur showed that there are 439 books. Here they are. Okay, all of them are available through scilab.in. Scilab.in, on the left hand side you have textbook companion project, completed books, books in progress, how your students can contribute, participate in this as an intern, and so on. All the information is provided here, and these are the completed books classified under some category. Okay. The other thing, I can go on talking, but I just want to give a flavor of this. Professor Madhu Belur talked about lab migration. That's also extremely important. We already have completed at least 30 labs. Lab migration means we talk to the people, who talk to the departments who use MATLAB. They have MATLAB based labs. We contact them and ask, would you want to shift your lab to Scilab? Right? And if you want, do you want help? Right? If they do it themselves, we give them a honorarium, but release that code as open source for other labs also to adopt. Or if they cannot, we help them. Okay. After all, a DSP lab created by one college or university will be useful to several other DSP labs, right? And we have done 30 labs already. So it is likely that all your laboratory requirements will already have been fulfilled by these. We already have them. And we have, we will also introduce our staff members. Is Shamika here? Yeah, Shamika, just stand up. She is coordinating the lab migration work. And then, yeah, for textbook companion, we have Lavita. Forget your name. Bhavani, sorry. I'm very bad with names. Okay, we have Bhavani and Lavita for textbook companion. Yeah, please be seated. They are going to be around. If you have any questions, you can ask them. Okay. I told you that we replicate this for all other things. Okay. The another one I forgot, which was the spoken tutorial. Now for spoken tutorial, let me just briefly show this. This is our spoken tutorial website, and on the very first page itself, you can use the arrow to go to the next page, but you can, very first page, you can get information on what topics we have spoken tutorials. So you can choose, for example, Scilab. Scilab, it says you have a total of 23 tutorials of 10-minute duration, and the spoken part we dub into various languages. Of course, one may ask, is anybody going to do higher education in anything other than English? But anyway, we have this. So here is one on why Scilab. Let me see if I can play this. You may not be able to hear because this, let's see.
ट्यूटोरियल में आपका स्वागत है। इस ट्यूटोरियल में आप Scilab पैकेज की कुछ क्षमताओं तथा Scilab में शिफ्ट करने के लाभों के बारे में जानेंगे।
Okay. So we have this, and in this, using this, I will also show you some statistics. Workshop training, and then here I want to choose Scilab. If I filter, you can see that we have trained a total of 51,000 people, you can see here, through about 1,300 workshops on Scilab alone. Okay, we have trained a total of about 500,000 people using spoken tutorials, using self workshops. We have Mohammed Qasim here. Want to stand up? So he's a staff member from the spoken tutorial project. In case you want to organize these workshops in your colleges, he'll be happy to put you in touch with the right people. Yeah, please be seated. So if you see, it is also possible for me to choose the date. So let me choose the date as 0101. So out of the 51,000 people whom we trained on Scilab, oh, I should have put 01. Okay. So this is the data I am presenting is for 1 year. Okay. So in this calendar year, we have trained close to 30,000 people on Scilab. Okay. Total number is 51,000, 30,000 in this year alone. Okay. It's just taking off. So we talked about three things. One is textbook companion. Second is lab migration. Third is self workshop using spoken tutorials. We are replicating this for every software in the FOSSEE project. We have lab migration for free EDA. We have lab migration for OpenFOAM. We have textbook companion for Python and so on. So now that we have a model, we can replicate. So that is the work done by the FOSSEE project. Okay, the idea is that once we identify a good model, replicate it. Okay, in the last few minutes, I want to talk to you about the one other project that we have embarked on. The reason for doing all these projects is to make IT accessible to all our children. Okay, and we have chosen open source software because that is the easiest way to scale, right? In fact, spoken tutorial based workshops, what the students are supposed to do is what is known as side-by-side learning. Open the software on one side of the screen and open the video on the other side. You have the video and the software. Now, you can open the software because it is open source software. If it is commercial, this model will break. Okay, then listen to a command in the video, try it out on the software. If it works, go to the next command. If not, rewind, listen to it and try it again. So this way we promote what is known as active learning. Active learning, the students are not passive, not just listening. They have to practice, they have to reproduce every line, every command, right? So all these things are getting replicated for all the software systems. One of the problems in all this is access to bandwidth, access to internet. So that is being made available, the prices are falling, 4G is going to come and so on. There is still another problem, that is the connectivity. Do students have computers? So that's why we came up with the Akash. As a continuation of that, we have come up with the netbook computer. So in fact, I have a sample with me. Those of you who want to play around with this can do this. It's a fairly light device. It's almost like a laptop, 700 grams. Let me get, I have Linux running on this. Okay, let me fire, before let me just fire Scilab. Okay, so I have Linux running here. In fact, I'm not able to project it right now, it didn't come. You can see a LaTeX running here. We have Scilab running, we have Java, we have Perl, Ruby, C++, all kinds of things are running. And it costs 5,000 rupees plus tax. And battery runs for 8 to 10 hours. We believe that it's a great system. We are talking about giving computers to 300 million students. Okay, they are the students we have. Scilab is, thank you. So here is a 3D plot of Scilab that I am plotting. You can actually see that thing coming up. You can see 3D plot requires a lot of computation, right? At one time, we needed heavy duty graphic engines, graphic machines. You can see that in this 5,000 rupee machine also, it comes. So we have a very nice system. So this is part of the FOSSEE project. We call it FOSSEE operating system, this distribution. So with this, I think I have given a fair idea of what we are doing, and we are just about time. We have probably 1 minute left, and Shamika and Bhavani are already here to remind me that it is time. So thank you. We'll be here, we are here mainly to discuss all these things. Okay? So your help is required to make our effort a successful one. Okay? Thanks for joining us.